Okay, I welcome you specially once more to our maths and science revision. We've been on this for quite some time. If you've missed any of the classes, please go search for the maths revision series. Okay, we're talking about physics, chemistry, mathematics. Okay, the subjects the students find a bit difficult. Okay, in today's class, we'll be looking at waves in physics. Okay, ever seen a stone, okay, that's thrown into a body of water? We discovered that there are some ripples that go off from the point of contact with the water. Okay, it goes out, in this manner. It goes out in this manner, and then you have something like this. Okay, this is kind of a disturbance or is a wave. A wave is a disturbance, okay, by definition, okay, that travels through a medium is a disturbance like this, okay, that travels through a medium, okay, and transfers energy, okay, as it moves from one part of that medium to another without a permanent displacement of the medium itself. So that's what a wave is. So this major diagram here shows us a basic representation of what a wave can be called. Meanwhile, you can see that the wave starts from here, it goes up, it starts coming down, it goes up again, it starts coming down, it continues that motion until when it stops. Okay, and it just transfer the energy it's required to transfer. Meanwhile, we have some terms that we need to acquaint ourselves with on the waves before we go into the calculation aspect. Okay, we're going to velocity, frequency, wavelength. Okay, we're going to we also have sound waves, we have light waves. Those are the basic ones we'll still look at. Okay, so but for this class is an introductory class in waves. We're going to look at this diagram on the board. I'm going to know the parts, okay, of a wave, the terminologies we can use. Now, from here now, we have a minimum displacement, okay. In a wave, we can have a point of maximum displacement, which is this, okay. The highest point in a wave is known as the crest, the highest displacement, while the lowest part is known as the trough. That's a wave. Now, also in a wave, okay, we have what we call distance that's been traveled. Okay, distance that has been traveled is known as the wavelength. The wavelength is the distance of the wave. Wavelength is expressed as lambda. Now, the wavelength or lambda is the distance it travels whenever it makes one complete oscillation. The oscillation is like from here to this point. Okay, this is one complete oscillation. A complete oscillation is as in made up of like 360-degree that's round. So this is a complete oscillation. Complete oscillation we say is what? 360 degrees. 360-degree or 2 pi. Okay? That's the time it or the distance it travels. Now, in a wave also, we have what we call the period. The period. The period is the time taken to complete one oscillation. Period is expressed as t. Okay, you can also say period is in seconds. Time taken for it to complete an oscillation. We also know what we call the frequency in a wave. The frequency. The frequency is like the number of times or number of oscillations or cycles that is completed in 1 second. Okay, number of cycles completed in 1 second. Number of cycles completed in 1 second. I hope you're learning. These are all terminologies we use in waves. Now, with regards to this diagram now, okay, we can say from this point to this point, I like to rub this off. Okay, let me just rub off what we have up here. I want to explain some things here, so I'll rub this off now. Okay, this is lambda. We say this is the trough. Now, from here to this point, okay, is called one complete oscillation, and the distance there is what? Lambda. Meanwhile, from here, okay, to this point here is lambda over 4, while from here, okay, to this point, okay, is known as lambda over 2. Take note, a half oscillation that's from here to here is 180 degree, that's lambda over 2. Complete one is lambda, while half of this is known as lambda over 4. That's a quarter cycle. That's lambda over 4. All right, so these are some of the terms we need to know, and also the maximum from here, from this point to this point, we say this is like the amplitude. This is the amplitude. Okay. Meanwhile, the highest level also attained by a wave, that's from here to here. This is also known as the antinode. Okay. This is also known as the antinode from this point to the highest point of travel. Okay, while the point of rest, this point where there is no displacement, this is known as node. Okay, where there is no displacement, this is known as node. Now, there exist relationships. Before we go over to types, or let's just look at types of wave. Okay, we can say a wave can be stationary, a wave can be stationary, that's non-moving wave. Okay, a wave can also be progressive. A wave can be stationary, a wave can be progressive. A progressive wave transfers energy from one part of the medium to another part. But a stationary wave can have um, waves traveling the opposite direction. Okay, okay, moving with equal frequency and okay strength. So, but the progressive wave now, basically, we'll be looking at it. Okay, progressive wave can still have under that we can still have a transverse wave, and we can also have the longitudinal wave. Okay, take note. The transverse wave, something like this, like where the wave travels in a like in a perpendicular direction. Let's put that way. Perpendicular direction, okay, perpendicular direction, okay, to the medium. While this longitudinal travels in what parallel direction to the medium. Okay, on the transverse wave, we got light, that's an example. On the longitudinal, we can have sound. Okay, so these are sound wave. Okay, under longitudinal. So these are some types of wave. We'll still look at properties of waves that involve reflection, refraction, diffraction, polarization, interference. Okay, but over here, let's look at some relationship that exists between frequency, time, velocity of a wave. The velocity of a wave measures the speed, okay, of the wave particle. Okay, so let's look at some relationships here before we round up this section of the class. I hope you're understanding what a wave is essentially. So, like we're saying that the relationships that exist. Okay, the speed of a wave as it travels is expressed as its velocity. So we can say that's velocity too. Okay, and this is equal to frequency over times wavelength. The wavelength take note is lambda. So we got lambda times what? Frequency. So in other words, we say a wave is equal to lambda f. The speed of a wave is equal to lambda f. That's one basic formula we have to take note of. Okay, now we also see that the frequency of a wave is inversely proportional to the period. Okay, or consider the period is inversely proportional to the frequency. Okay, that's also another relationship we need to take note of. As I said, lambda is equal to the distance traveled, okay, in one complete oscillation. And I said this, the oscillation is like 360 degree or 2 pi. And that's from here to this point. I hope you follow it. So in the next class, we'll try to look at one or two calculations that involve these parameters. Okay, and then we'll also go into properties of waves. Okay, I hope you've gained one or two things of knowledge in this class. Okay, I'll see you in the next class. Thank you for watching. If you have not subscribed to the Supernovas TV, please do so. Okay, we give you or simplify physics, chemistry, mathematics for you, for all students. Okay, in and outside the country. Thank you. I love you so much. Bye.